Functions can shift left and right and up and down, but they can also stretch and they can also shrink from the parent function. So this learning target is going to talk to us about what that might look like. So on this graph I have in front of you, I've got the parent function in that blue color. Okay, and so what we're going to do is we're going to graph the other two types of functions right next to it, and you're going to see what the stretch and shrink looks like. So this guy is your parent. I'll make that blue so we can see that easier. So y equals absolute value of x is your parent function. That's that guy right there. Okay, just your basic starting at 0, 0, going up 1 over 1, up 1 over 1. Now, I want you guys to remember that y equals mx plus b. This is a graph of a line, right? Where m is your slope and b is your y-intercept. The same way that this number in front of your x is the slope behaves the same way in absolute value. This number in front of the x behaves as your slope. That is the same thing in absolute value functions. That number in front of the x is your slope. Notice in the blue one, in the parent function, there is no number in front, but that is an invisible 1. And you see how you go up 1 over 1, up 1 over 1, up 1 over 1? So that 1 is your slope. So the cool part about this is that you can shift it left and right, up and down, but then also you change the slope of the two lines that extend from wherever you shifted it from. So I'll show you what I mean. So let's take a look at the purple one, okay? It's 1/3 x. So I'm going to start here at the middle. Nope, let me change my color. I'm going to start here at the middle because there's no shift left or shift up and down. It just has the x alone in there. So now my next point, I'm going to go up 1 over 3. Up 1, 1, 2, 3. Up 1, 1, 2, 3. Okay, now on the left, I'm not going to go down and keep going down like a line. Instead, I'm going to go up 1 over 3 and start making a V. And now you'll notice that this V that I've made looks different than the parent function. Okay, when it starts to go out like that, that is called a shrink. Okay. And this is going to be true anytime the number is between 0 and 1. So anytime the number in front of the x is between 0 and 1, it causes the graph to shrink. And you almost kind of want to think of it as like getting shorter, like you're squishing it, right? Because it's getting flatter, so it's shrinking down. Okay. On the other hand, let's do the red one. The red one, I'm not shifting it left, right, up, or down either. I'm still starting at this middle point, but now I'm going to go up 3 over 1. So 1, 2, 3 over 1. 1, 2, 3 over 1. And then the same thing on the other side to make that V. Now notice this V is a lot taller. Okay, it's going up higher, higher, and that's going to cause the graph to stretch high. So we call these two different changes in the parent function a stretch, and a shrink. So anytime the number is bigger than 1, then it's going to be a stretch. Okay. So let's practice putting this all together with what we learned before. Wow. Now we're going to put together left-right shifts, up and down shifts, and stretching and shrinking. So the first one, y equals 2x plus 1. The first thing is going to be a shift to the left 1. Then I've got it multiplied by 2. That is a stretch of 2, which means my slope basically is going to be going up 2 over 1, okay, because there's a little invisible 1 under there. So I'm going to go ahead and move my point left 1, okay, and then I'm going to go up 2 over 1, up 2 over 1, up 2 over 1, and make my new points. And that becomes my new graph. Okay. The second one, now I've got 3 different transformations. I've got a right shift 1, that's coming from the inside here. I've got an up 2, that's coming from the plus 2 at the end. This is going to reflect, and it's going to shrink by 2 over 3. So let's take this one step at a time. Let's do the right 1 and the up 2 first. So I'm going to go right 1, up 2. There's my starting point for my graph. My slope, or my new slope for my lines is 2 over 3, but it's going to be going facing down. So I'm going to go down 2, 1, 2, 3 this way, down 2, 1, 2, 3 that way, down 2, 1, 2, 3. So I'm making my points go down and this graph will look wider. Okay. The last one, now I don't have a left or right shift, but I do have a down shift of 3, and I have a shrink of 4. So I'm not going to move it left or right, but I'm going to go down, and then my new slope is going to be 4 over 1. 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. Okay? So that is my new absolute value graph. Okay? So you've now learned the 6 different ways something can transform in an absolute value function. Left, right, up and down, shrink, or stretch. The last thing that is part of this unit is talking about domain and range. And we talked about this in a previous unit, and it was a struggle. But I'm going to loop this back into every other unit we have pretty much. And then that is being able to tell what all your possible x values are and all your possible all your possible y values. So domain, I'm going to remember this. Domain is all possible x values. And remember, we think of domain as left to right. So in number 1, domain, I'm trying to figure out how far left this graph goes. It looks like it goes all the way over to here, and how far right it goes. It goes over to here. Now remember, arrows on left and right means it goes on forever and ever and ever. So my farthest left point isn't this -4 here. Even though it does stop at -4 on the x, it actually goes to -infinity. And on the right, it kind of looks like it might be at 4 as well, but since it has an arrow, that goes to +infinity. So my domain here is -infinity to infinity. I'm going to give you a big hint. On all absolute value graphs, it always is going to go from -infinity to infinity, because they always have arrows going left and right, left and right. Same thing on the second two. Always going far left, far right. That's -infinity to infinity. And the domain here is -infinity to infinity. So for absolute value graphs, the domain is always -infinity to infinity, which is really awesome. That makes your guys' lives a lot easier. The tricky part then is finding the range. Now range is all your possible y values. Okay, and that is your bottom to top points. So for this first one, where is my, I'm going to erase the green here, my farthest, where does this graph go down? Where's the stopping point on the bottom? There isn't a stopping point on the bottom because you've got these arrows here. They go on forever and ever. So your lowest y value is -infinity because it goes on forever. However, this graph stops right here at -2. So your range is -infinity to -2. And instead of a parentheses, I'm going to put a bracket because the point physically lies on there. Now this learning target, I'm not going to be particular about your notation. If you want to write it like we've done in the past, where we have this and then the less than equal to -2, you can do that. For this learning target, I'll take one or the other. It just has to be correct notation. If you're missing a bracket or you don't have the right parentheses or a sign is wrong, it will be marked wrong. I care about notation for this, okay? The range for this next one, my farthest bottom point is now that thing. And that lines up with 2 in the y, so my very lowest point is going to be 2. My highest point, those arrows go up forever and ever and ever, so that's going to be +infinity. Okay. The range for this one, -infinity. I know that because I've got the arrows here and here, but it does stop right here at 0. I know it looks like 1. I know you see the number 1 and you think that's a 1, but that's a 1 on the x. We want on the y. This point is the point 1, 0, and that's your y value is 0. So it goes -infinity to 0. Remember, range, you can only have y values in that range. You can't have an x value in the range. Doesn't make sense. And finally, for this last one, my lowest point right here is 2. And that goes up to infinity. Okay. So this was a short video. Your practice will take you longer than the previous practice. It's just a little bit more lengthy. You have to think of a lot of different transformations, but I think a lot of you will probably get done today. So good luck. Don't be afraid to ask questions, and this is your last learning target for this unit.